Hello, good evening.
Yeah, good evening.
Yeah, I'm really sorry for just joining. I went to join with um, the wrong link.
No problem, no problem.
Yeah, right. So how are you doing now? So let's just let's just go through the last. Let's go to the last class or something that we had. Um, I think some of us are just we didn't join in the last class. At the last, what should I call it now? Is it class or call? Yeah, the last call. Um, but I don't know. Anybody that was on the last call, yeah, can you just run through? Okay, let me first see what we covered on the last call was just blockchain, its definition, the basics. When you hear blockchain, what does it mean? Decentralization and distributed ledger technology, consensus mechanism, that's proof of work and proof of stake, and then cryptography and security, just the surface. So, and I really went through a lot of things. Those that missed it, probably you watched the recording. I don't know. And I said from next week, we'll start writing Solidity properly. Yeah, we'll start writing Solidity properly. So I don't know who was on the last call. I think uh, oh, there's a Royal Uche. You were on the last call, right?
Yeah,
Oh, okay, okay, okay. Um, Probably like because I want to make sure that everybody at least we're following through. Maybe you can just run through like the basics of blockchain, explain the concept of like consensus mechanism, um, um, decentralization and distributed ledger technology. Just like run through it so that the guys that are just joined today too can pick up one or two.
okay. From the last class, we spoke about briefly about blockchain and what blockchain entails, and you spoke about give us the definition of blockchain. And from definition, you said blockchain is a distribution of immutable ledgers across different nodes. So the basis of blockchain is that the concept of blockchain comes from the fact that um, people can tamper with transaction. So because of trust, that's why the blockchain was created, so that we won't put our trust on people. Instead, the trust will be amongst ourselves. So for blockchain works in such a way that once a transaction is being created, everyone can see it and everyone has to agree on it before it is accepted. So that's what they call consensus mechanism. Is the mechanism in blockchain that all nodes must accept the transaction before it's being added to the blockchain, and this ensures security of the blockchain. And also it makes sure that uh, the any node, nobody can easily tamper with the blockchain. Again, we spoke about solidity, the fundamentals of solidity, the things we need to know to be a smart contract developer, and I think that's most of it. Thank you.
Okay, you really, really did well, and I'm glad that that means you really went through it. So you already explained everything. There's nothing for me to explain again. So you said everything. You've gone through everything we did on the last call. So today or this night we'll be going to before we move to Solidity proper next week, we'll be going to Ethereum, like details about Ethereum virtual machine, that's EVM, then smart contracts and their applications, then the Ethereum ecosystem, different year of wallets, exchange, so wallets in the Ethereum ecosystem, exchanges, then dApps, decentralized applications. I'm trying to, because I'm going to be showing you how a smart contract looks like on this call. So uh, for some of us that have not written smart contract before, so I'm going to show you how it looks like. So, but first off, let me first like run through what's Ethereum, what are EVM is, what are smart contracts, and all. So, uh, so Ethereum is a decentralized open source blockchain platform that enables the creation and execution of smart contracts. Yeah, before Ethereum, Bitcoin was the first blockchain, and BTC was the first blockchain coin, and it was introduced in 2010. First off, it was first Bitcoin white paper was written in 2009, then 2000 by in 2009, and then Bitcoin was released 2010. So as at then, Bitcoin was not open source. People could not like build on top of Bitcoin until recently that Bitcoin, a lot of like developments started going on Bitcoin ecosystem. That's a year Lightning Network. I don't know if you guys have heard of it before. Lightning Network is on, and then when you hear of this thing, Ordinals. So those are like developments built on top of Bitcoin ecosystem, and they are just of recent. But as at when Bitcoin was released, Bitcoin, you could not build things on top of Bitcoin until the founder of Ethereum, um, that his name is somehow to pronounce, and um, I've forgotten the pronunciation, sure. But if you see him, he's a lean guy like this. He doesn't even mind the way he dresses, he just moves and all. So the guy created Ethereum 2015, Ethereum was released. So Ethereum is just like Ethereum itself, is a blockchain. You get, it's decentralized and it's open source. That's why, and Ethereum is a layer one blockchain. You get, so most EVM compatible chains are built on top of not most, all are built on top of Ethereum. They call them layer one chain. They're just a fork of Ethereum with scalability. Some of them are side chains like Optimism. So um, to solve issues with transaction processing, gas fees, and all. Because Ethereum, gas fees are usually high, transactions usually take more time to process, you get things like that. And I explained the way transactions are processed, like the flow on the last call. You get, I said when on Ethereum, let's say on Ethereum now, once a transaction is carried out, is signed, that transaction is being that transaction has to be validated by a validator before it's been added to a block, which is then added to a node on the blockchain. So is this interconnection of different nodes that form the blockchain? You get, and those nodes are filled with blocks, and those blocks are filled with transactions. So um, the Ethereum blockchain itself allows us to create smart contracts. These smart contracts are like agreements. You get, that when they are deployed, they can't be changed. Just like we have in the centralized world, where um, when you want to, let's say, work on a contract, you sign an agreement and no, you sign a contract, and a lawyer will be there and no. So on the blockchain, the smart contract is serving as the law. You get that is binding a set of instructions. You get, and once those instructions are put in place, it cannot be changed. You get, so key features of Ethereum. We have like smart contract functionality. You can build smart contracts, the EVM, and then Ether. ETH is the currency for Ethereum, just like Bitcoin. BTC is the currency for Bitcoin. So, um, what are the like key differences between Bitcoin and Ethereum? So, we have like I said, you can build limited scripting capabilities in Bitcoin. It's just recently that they released like this Lightning network, and people are then building on top of Bitcoin. But Ethereum, we're building smart contracts from its creation. You get, so um, and then Ethereum is the black platform for decentralized application. That's dApps. Most web front ends you can see built on top of the blockchain are called dApps, decentralized applications. So um, ETH, Ether. When you hear Ether and gas, ETH is just the native currency for Ethereum and is used to pay transaction fees and computational services. So when I was explaining consensus mechanism in the last call, I said Ethereum now uses proof of stake. So whereby the validator a stakes at ETH, you get, on the blockchain, on the EVM, and then um, they have to make sure that they abide by the rules, you get, and they don't break that consensus mechanism, else they are going to be penalized for it. So, and it's more like the person that has the highest stake is the one that will be earning more rewards, like from gas fees, you get. So, um, for gas is the unit that measures the amount of computational effort required to execute operations. It's used to calculate transaction fees. It helps prevent spam and allocation of resources to the network. So, like even when you're writing smart contracts, yeah, when we start writing smart contracts, you have to make sure every line of code in Solidity uses gas, uses what they call gas. So you have to make sure that the code you are writing is optimized, and then sometimes when you are doing computational intensive calculation, you have to structure it in a way that you have to optimize gas. You get, if not, to run your smart contract, if it wants to sign the transaction for any of its functions, the your end users will have to be paying like a lot of gas. Yeah, that's why you have to know smart contract optimization techniques and all. So let me explain the. Oh, wait, I didn't even. Can do you guys understand all I've been saying since?
Yeah, yeah, I understand.
Yeah, 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 yeah.
Okay, okay. So please, if you have any question, you can ask me. So moving on, we have the Ethereum virtual machine, the EVM. So basically, the EVM is just the runtime environment for smart contracts in Ethereum. It's completely isolated. So the code running inside the EVM has no access to the network, the file system, or other processes. So the EVM is just like a normal Web2 technology. When you have for different languages, you get, for different languages like Golang, Python, all of them have their, okay, let me use Python now because I write Python very well. So Python has its own compiler. You get, there's C Python, there's J Python. C Python is the compiler for written in C language that compiles Python code. Yeah, because Python is a high level language. So most of these languages they have their own runtime. You get they have their own runtime. Python, JavaScript, the JavaScript runtime is there. Golang, the same thing. So same thing for Solidity. Solidity is the language for Ethereum. So it has its runtime called the EVM, Ethereum Virtual Machine, and then it runs with no access to the network or the file system of the blockchain. Now, what are the key concepts you need to understand about this EVM? We have bytecode. Smart contracts are compiled into EVM bytecode for execution. So it's more like the way your computer now, like instructions you give to the computer does not understand English, it just understands zeros and ones. Those are byte codes you get. So the byte code of the smart contract is compiled into the EVM so that it can be executed. You get. So it's just like your normal if you programmed in any programming language before, if this Solidity is not your first language, so you would understand it perfectly. Then gas, every operation in EVM costs a certain amount of gas, and as I explained earlier, and this gas is paid in ETH. So we have the EVM is stacked based. So the EVM is a stack based machine with a depth of 1024 items. So that's just like these are some of the things that the EVM comprises. So uh, let's go to the next one, smart contracts. Yeah, smart contracts. What are smart contracts? When I hear the word smart contracts, like I explained earlier, smart contracts are like agreements. You get they're like agreements that are written in form of code. You get, and then you can execute them automatically once those conditions are met. You get a smart contract is autonomous. That means once it's deployed, it they operate independently. Then they are deterministic. The same input always produces the same output. So that's what it means by like as you give it, it's more like garbage in, garbage out. So once the instructions you give it, that's what it's going to do. Then it's transparent. So the terms are visible to all parties. So just like voting systems, escrow services, their smart contracts are visible to everybody. You can see it. Everybody will come to an agreement, and then let's say an escrow service, they will see the amount that is being contributed into that smart contract as everybody are depositing money into the smart contract. So I think I should just give an example how a smart contract looks like for some of for so for some of you that have not seen it before. Um, let me share my screen. How do they share screen on? Okay. Yeah, can you guys see my screen?
Yeah, you can see the screen.
Okay, so this is Remix ID. It's just is an online ID for running smart contracts. Get so that's what we'll be using for the basics till we want to create when we move to Foundry. We'll now use VS Code with the tool. So let me create let's say example dot tool. Sorry. creative files. Example.sol. So all Solidity files are in .sol. It has .sol extension. So when you want to start a Solidity program, you have to first do this. I have to let me use this pragma. You have to say pragma Solidity, and then this comment is going to come SPDX license identifier MIT. It's just a comment that Solidity just used to um, it's just a license share that they give to all smart contracts for the version you are using. So you will now specify the version that you are using. Let's say 0.8.5. That is 0.8 upward, 0.8.0 upward. You can use this, you can decide to use this asterisk, or you can decide to use greater than or equal to. You get maybe from 0.0.0800 greater equal to blah, 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 blah. No, it's going to be greater than equal or equal to. So, but it's advisable to use this. What do they call this symbol again? I've forgotten what they call the symbol.
Ampersand.
Eh?
Ampersand.
Oh, okay. Alpha sign. Yeah. So you have to declare your Solidity like this at the top of the Solidity file. Then for you to create a contract, that's a smart contract, just write the keyword contract, then name your contract. Let's say example, then you put a curly braces. What do we want our contract to do? Let me declare a variable. So I don't want to go into that now till next week, but just look at what I'm writing. So an unsigned integer is basically just a whole number. That you in 256. I'm basically saying the highest number that this unsigned integer can take is 2 raised to power 2 raised to power 256. So 256. This 256. That's going to be 2 raised to power I think 16 minus 1 or thereabouts. So it's going to be 255. That's the highest number that this thing can take. 255. So you're in 256. Let me say what do I call this now? Let me call it, okay, it's an integer. So let me say number, and then let me give it a number 3. You always put a semicolon. Sorry, not semicolon. This colon when you finish a line of code. So it knows that this is the end of this line. Then let me create a function, or let me just say, let me call this counter. Then let me create a function increments. I just want to create a smart contract. That's a function that increments this counter. So it's going to be public. Let me make this public. So public and returns you int 256. You don't need to understand how this works. I'll explain it. Yeah. So you can see when I said every line of code like runs with gas, you can see this is saying 329 gas. Then return counter. I'm returning counter plus equal to, so counter plus plus. So I'm incrementing it, enter my call counter. So if I deploy this contract to, I think it's auto compiled, auto compile. So now I want to deploy this contract. So this is the contract under here. Then I can see that counter is 3. If I press increment and I press counter again, it has increased to 4. Can you guys see it?
Yes, you can see it.
Okay, okay. So it's just a simple functionality. Counter is 3. Anytime I press increment, it just keeps increasing, increasing. So I press it again, increase to 5. Press it again, increase to 6. So this is just a simple contract chart just to show you how Solidity looks like. So can you like just let me know like how do you see the syntax of Solidity? As if you write if you write JavaScript, you know that it's looking somehow like JavaScript. It's looking somehow like JavaScript. So it's not Solidity is not hard. It's not a hard language. It's easy to learn. It's just you being professional about it now to optimize it for gas. So, so let me get feedback from you guys. Is it looking like a language that, for some of you that are just like, probably you're just, so maybe Solidity is your first language, or you're just, you just want to learn Solidity, you've not seen it before. Is this something that, is the syntax okay to you?
It looks chill. Looks chill.
Okay, okay. How about the others?
It's okay.
Okay, okay. So don't worry, as time goes on, yeah. So let's move on to the next thing. So we have reward application of smart contract. It's when you start building stuff with Solidity, you start see the you start feeling it. Get so reward application. We have DeFi. Get this DeFi means decentralized finance. So under DeFi is the most is still the most, will I say, it's still the most used part of blockchain. You get so smart contracts, most smart contracts are built DeFi related.
Hello. Hello.
Hello, is anyone talking?
Sorry, can you guys hear me?
Uh, Yeah, Divine, we can.
Sorry, my browser just refreshed. I don't know. Yeah. So, as I was saying, so you can do smart contract auditing. You can do you can become a smart contract engineer. So if you're writing smart contracts, you can audit smart contracts. Um, you can even go into tokenomics engineering. That has to do with writing if you write. So there are different fields you can go into in the Web3 space. So as I was saying, real world applications of smart contracts, DeFi. Then we have supply chain management. So people use smart contracts in supply chain. That's tracking products from manufacturer to delivery. That's like logistics. Then digital identity. So some people use it for identity solutions. Some people use it for voting systems. So some people use it for insurance system. There are some insurance protocols that people use. You get so now let's go to the Ethereum ecosystem. Under the Ethereum ecosystem, we have wallets. Yet, so I don't know if any of you have wallets already, but there are different kind of wallets. Yeah, there are hot wallets. Those are the ones that are connected to the internet, like MetaMask, Phantom. Um, which other wallet again? Your Trust wallet, um, Fair, different wallets. Then Coinbase wallets. Those are hot wallets. Then we have cold wallets. So those ones, they're like offline storage. So these are like hardware wallet, like Ledger. I don't know if you guys have seen a hardware wallet before, but it's just like it's like a somewhat like a key shop, but it's hardware. You can store your Ethereum, your Bitcoin inside it. You get so those are hardware. That's hardware wallets. But the advantage of these wallets is that you have full ownership of your assets. So you're the one that control the private key, and but just make sure you don't lose the private key. If not, you can't have access to the wallet anymore. So these wallets are they are non they are non-custodial. So you have like full control over them. Then we have exchanges under the Ethereum ecosystem. So under exchanges, we have centralized exchanges. They call them SEX, and then DEX is decentralized exchanges. Example of centralized, those are the normal ones you know: Binance, Coinbase, the ones you've used, Bybit. Then we have, but the key difference between these centralized exchanges and decentralized exchanges is that DEXs are that decentralized exchanges are operated by smart contracts, pure smart contracts, like Uniswap is pure smart contracts. There's no like central authority. You get that's why in Nigeria, when they used to say they ban crypto, they can't ban Uniswap, they can't ban PancakeSwap, they can only ban Binance or Bybit because they are centralized exchanges. So in a way, the government still have like say over them because they are operated by a company. You get so then what are dApps? Decentralized applications. So they are just applications that run on the decentralized network, as the name sounds, dApps, decentralized application. So a dApp is usually open source, is usually decentralized, and then it is tokenized. So most dApps used to have like tokens, like most dApps, whether DEXs, you see them launching token. There are different token. Can you hear me?
Yeah, yeah,
Yes,
loud and
clearly.
clear.
Okay, okay. So, an example of dApps, like I mentioned before, Uniswap, Eve, OpenSea. OpenSea is an NFT marketplace. So that's just like the overview, like of the whole Ethereum ecosystem. You've seen an example of smart contracts, EVM, we explained Ether and all. So, um, I think that's all on the theoretical part of blockchain and Ethereum and the Ethereum virtual machine. So from next week, we'll start Solidity. So we'll be doing things like you write like your first hello world, build your first app, you learn about data types in Solidity, you learn about variables and constant, immutable variables, reading and writing to state variables, ether and way, gas and gas price. So yeah, that's what we learn for next week. You get. So um that is it basically. So does any of you have any question? Do you have any question? Oh, wait, when I left this call, did the recording start again? Because from what I'm seeing here, I can only see six
I have
minutes.
no idea.
Oh, that means the recording started again. Wow. That means people that didn't come to the class. Well, I will just have to run through run through it probably in the next class. So that's it. Does anybody have any question?
Yeah, I have two questions.
Okay, okay.
Uh, my first question is, how are we going to learn how to use Git, also like GitHub, Git, and also after the end of this training, are you going to give us a certificate?
Mm, well, for Git, yeah, we can just learn the like while working, yeah. Let's see, because when we learn the basics of Solidity and oh, we are going to use Remix, yeah, but when we want to set up our smart contract environments, when we start using Foundry, we are going to use VS Code. So I would show you how Git is. We can, yeah, like, because I will just push the code, the final code of what we do to GitHub, and then I'll just send it to you guys to so that you can read through the code or clone it or something. So, but Git is not hard. You can just watch a 1 hour YouTube video or something on Git, basics of Git. It's not something hard. Then certificate, no, there will not be. I don't know, Sha, but I don't think they are giving certificate. But certificate does not matter. Yeah, the main thing is just to build solid projects. Can you hear me?
Yeah, you were out before, but yeah, I can hear you now.
Okay, so I think certificate does not matter. The main stuff is just to build solid. I scratch. Yeah, look at existing protocols. Like now, we are going to build Uniswap clone. Uniswap already exists. You can say you want to build a lending and borrowing platform, smart charts. So different things, or one other thing you can do, prompt ChatGPT. Oh yeah, what are like 5 solid projects I can build to solidify my portfolio? You get. Hey, I didn't even mention another thing you guys can explore too is in this Web3 space is technical writing. Yeah, you can, and if you are doing technical writing, look at all these non-popular protocols like SU or C, but just at those ones, they are not written in Solidity. C is written with Move. There's this language called Move, MOV. That's another language for this thing. But you can contribute to their developer documentation. You can search them on GitHub, open a pull request, like just do something. So from there, you can just pitch them that Omo, you want to write for them or help them with their docs. So you can do technical writing in the Web3 space. So and then you can decide to just like writing smart contracts. So one thing you can do is that you can, if you know you want to work for protocols, build like you can build like solid projects, smart contract projects, and then just they should be in your, you can like put them at the top of your GitHub, like state them, and then reach out to these new projects. Look at less competitive protocols, then look at new projects coming on board. You can pitch them, reach out to them, like maybe on LinkedIn, look up their CEO. That's like cold emailing, and then just tell them one or two about yourself and all you should. You can even tell the things that you can ask. Okay, how can you approach the CEO of this particular protocol? Please details about the protocol. I know. I'm very sure if you bomb, we call it bombing. If you bomb like that for like a month or more, you get an offer. Especially if you have like you already have these projects to show, you get. So and then another thing too is that you can, this Web3 space, there's always like money is flying up and down. You can build your own stuff. You have an idea, you have something you want to build in the Web3 space, build it on a particular protocol, pitch to them, they can give you grants, you get. So there's a lot of stuff you can do. Yeah, what did you say? So did you ask a question? Okay. Okay, so does anybody else have any question?
Are there any technical writing documentation or stuff we can learn with?
Okay, I think I'm going to like one of my guy. I think I asked him that what resources, because me when I did technical writing, I did not actually learn technical writing. I just started writing. Just started writing. So I just used my knowledge of, as far as I can break down concepts, I just started writing and then probably just use, you can use GPT, okay, bring sections of this particular article. You get, that's for article. That's not the only part of technical writing. And that part is writing developer documentation. So I have to, I have someone sent me some resources, I can forward them list. So mm, that's it. So any other question? So do you guys have any other question?
Not none for now.
Okay,
No.
okay. So that means in the absence of no question, that means we are done. So till next week, Wednesday. So I wish you guys a good weekend, and you can just reflect what we've learned. Yeah, that reminds me too. I'm going to send probably by tomorrow. I will send a document, a more like a quiz assessment document that is going to test your knowledge on what we've done so far. So, and I want everybody to participate. So, yep. So, so
Okay.
yeah. And so, see you guys. Good night.
Good night. Good night.
Yeah.
Right.
Yeah.